Hello everybody. In this video we're going to talk together about the rules of the functions derivatives. Before we start talking about the first rule, let us know these symbols. When we have function like y is function of x, and we need to write the derivatives symbol. There we can write symbol like y dash. It refers to the derivative of the function. Or we can use dy by dx. So these two symbols can be used to refer the same meaning. During the solution of the problems or questions, we will use sometimes this, sometimes this. And don't be confused because they are the same meaning. Okay? Now we start with the first rule. If we consider y, as we said, is a function of x, where f of x is x to power n. So we can say the derivatives for this function is y dash is n multiplied by x to power n minus 1. Well, what we do, just bring the power in the beginning here and write x with power not the same but less than by 1. So the power will be n minus 1. It's very simple, like if we can say this example, if we can say y is x to power 5, its derivative y dash is y dash first is equal 5 multiplied by x to power 5 minus 1, that's mean 4. That's it. So it's very simple to remember. This is the first rule. Now the second rule. If we have y is a product of multiplying two functions together, like f of x multiplied by g of fx, g of x. So the derivatives will be y dash plus g dash x times fx. If we write it like this way, that's fine. If we need to write this in the beginning here and this in the end, that's fine, because of the addition. Addition is commutative. It's easy to also remember this rule. Example, simple example, like y is equal to x cubed multiplied by 5x squared. So it's easy to write the derivatives as y dash is equal the derivative of the first function 2 times 3x squared. This is the derivative of the first function multiplied by second function without making derivatives for it, plus the derivative for the second function, which is 5 times 2x, multiplied by the first function without derivatives. After then, you can remove the brackets and simplify the answer. Okay? So this is the second rule. Let us go to the third rule here. I will write it in another color. The third rule, when there is division, when there's a function result from dividing two functions together, like y is equal fx divided by gx. In case of division like this, so that y dash is equal, here fraction line, in the bottom we write gx squared. In the top we write f of x minus f of x multiplied by derivative of gx. So be careful here, because we have the subtraction. We have to keep those terms in their places. That means this cannot be written in the first, or this cannot be written in the end. If we take example like y is equal 3x squared divided by 5 minus 2x. Here's fx, here's gx. So the rule said the derivative y dash is equal, first of all, we make the line of fraction, and this bottom we will write it squared. F minus 2x all squared. And the top we will write the bottom, which is 5 minus 2x multiplied by derivative of 3x squared. Derivative of 3x squared is 3 times 2x. Okay? Then the sign minus here. The sign in the rule is minus. That's why we wrote here minus. Top of the function multiplied by the derivative of the bottom. The derivative of the bottom, derivative of 5 is 0, derivative of 2x is 2. And the minus also is there. So minus 2. And also we remove the brackets and make simplifying. We will explain how to do that in more examples after we finish mention the rules. Okay, this is the third rule. Let us go to the fourth rule. The fourth rule, what's the chain rule is? The chain rule say when we have function is in the form f for another function like g of fx. Gx, which is inside the brackets here, dash multiplied by f dash. Let me say I have the function y, this is an example. Y is 4x cubed plus 3x squared all to power 5. Look, this form is here gx. Inside the brackets is gx. And fx is all that to power here gx to power 5. Or we can write it like y is equal f of u, and u is another function of g5. So the function derivative in general will be y dash is equal 5 u to power 4 times g dash x. That's mean here, if we want to substitute about u by this value, so it will be 3 plus 4x squared all inside the brackets, and now the power, instead of 5 it will be 4. Then find the derivative of gx. Gx, it's u. That means we have to find the derivative of what inside the brackets. What's the derivative of what inside the bracket? It's 2 times the 3x squared, that means 6x squared, plus 4 times 2x, that means 8x. And that's it. And also we can make simplifying if there is any. This rule is known as the chain rule. The chain rule, its name comes from we can make the derivatives a few times. Let me explain that by example. If we have a function like this, let me write for you function with 3 variables, like y is a function of u, and u is a function of x, and x also is a function of, let me say, t. See how many variables are here? U and x and t. When we make this in 3 steps. First, we find dy by du. Second, we find du by dx. Third, we find dx by dt. See, it's like chain. One leads to another, the another leads to the third, and so on. If we have more than 3 variables or 4 variables, whatever the number. That's why we named this rule as the chain rule for derivation. Okay? We need to know another rule. The next rules, the rules for the functions of trigonometric, like sine x, cosine x, tan x, and also secant x, cosecant is x, then cotan x. So we need to recall all the rules about the trigonometric functions mentioned here. The derivatives for the first one, derivative for sine x. If we write like d by dx sine x, that's mean the derivative for sine x. It is simple to say it's cosine x. Derivatives for cosine, we can say it's sine because there should be minus. It's minus sine x. Derivative of tan x, d by dx tan x is 6 square secant, x. And derivative for secant x tan x. Here's 2 multiplied together, secant and tan. And d by dx for cosecant is minus cosecant x times cotan x. And finally, d by dx for cotan is minus cosecant square x. I think you get confused a little bit about minus here, and the others without minus. You don't need to be confused because we can observe that any function starts with symbol C, letter C, here, letter C, here, letter C, here, letter C. We put minus in front of its derivatives. So easy to remember that. Which start without any letter different than C, we do not write sign minus in front of its derivatives. So easy to remember that. Now, as we mentioned all the rules about the derivatives of functions, let us go and apply these on some examples. Example 1. Find the derivative of the function y is equal x power 2 plus 4x plus 6 all to power 5. So what is dy by dx? Y is equal f of x to power n. We can consider y dash or dy by dx is n times all what inside the brackets to power n minus 1 times derivative of what inside the brackets. You see, this is the rule we mentioned. So we will apply it right now. First, derivative of all this to power 5. That's mean 5, all the brackets stay inside, and here the power will be 4 times the derivative of what inside the bracket. What inside the bracket? Its derivative 2x for x squared is 2x plus 4, derivative of 4x is 4, and derivative of constant is 0. So it's gone. So here we will write all what inside the brackets, which is x squared plus 4x plus 6. This is the answer for the question. Let us go to another question. Example 2. If y is cosine of what? Of tan x. Cosine of tan x. Like we can consider this as u. So the function change into cosine u, where u is tan x. And we need to find dy by dx. Find dy by dx. So we'll do as the chain rules said. First, find dy by du, then find du by dx, and multiply them together. So we write dy by du and du by dx, then dy by dx, which is the multiplying of these two results together. The first one, dy by du, cosine, its derivative minus. Here, remember, we said when we start with letter C, we put minus in the derivative. So here's minus sine u. And here, du by dx is equal sec square x. Now we multiply those together, and also as u wasn't in the beginning of the question, so again we will write instead of u the value which was here on the question. So the answer will be multiplying those together. That's mean minus sine of what? Of u. U is tan x. We suppose it is from our mind. So tan x multiplied by 6 squared x. We can write it here in the beginning as it is multiplication. We can make something in front, something in the end. No change in the meaning. So we can write minus 6 square x sine tan x. Okay, this second equation. Another example, if we have like example 3 here, example 3. If we have like y is equal, it can be referred to power half. This can be written in simplest form without a radical sign. We can write it as sine x to power half. Also, we will follow the same as we did in the previous example. We can say dy by dx is equal. First, take this power, put it in the front here. Same inside the brackets. And the power here 1/2 minus 1 times the derivative of what inside the brackets. Derivative of this is cosine x. And we can write it in simplest form. Here, line of fraction, because the power here will be in negative. 1/2 minus 1, that's mean minus half, minus half. That's mean 1 in the top, 2 in the bottom, sine x in the bottom to power half, because when it's with power minus, we can put it in the bottom and change the sign of the power. Power in minus, put it in the bottom, change the sign of the power to positive. And here in the top, cosine. Also, we can write in simplest form. That means fraction line. 1 times cosine x, that means cosine x. 2, and this power half, we can change it also to sine of radical. That means sine square root of sine x. That's dy by dx, or y dash, whatever. It's the same meaning. Okay? Another example. Example 4. Let us say we have y is sine. Look what's the difference between the previous question and now. Here we put the radical sign on all sine x. Here we will put in this question the radical sign only over x. So how can we find dy by dx here? Also, you consider as this is u, let me suppose it is u. We can do it right away, but I want to explain for you what we will do. Here, if I consider it u, so the question changed into y is equal sine u, where u is square root of x. Then to find dy by dx, we said dy by dx is dy by du multiplied by du by dx. So we will do the first one here and the second one here. Okay, let us do it now. Dy by du, that means the derivative of this. What's the derivative of sine? It is cosine. So here we write cosine u, and we know u is the square root of x. So we write square root of x. And the second here, du by dx. Here u by dx. That means derivative of square root of x. It's 1/2 times x to power 1/2 minus 1. Okay, then we simplify all this answer. To simplify all this answer, this cosine square root of x times here also 1/2, this 2 in the bottom here, and this because the power now will be negative, 1/2 minus 1, that means minus half. So to change into positive should be put in the bottom, so it will be x to power 1/2. And again, x to power 1/2, we can write it the radical sign, so it will be cosine square root of x in the top, and in the bottom 2 times square root of x. This is the answer for dy by dx. That means dy by dx is this answer. Finally, I will give you the last question now. Let me say we have this example 5. We have y is equal tan of what? Tan of cosine x. So how can we find dy by dx? We will follow the same as we did before. Consider this is any symbol like u or anything. Here to solve, we put u is cosine x. Then the question changed into y is tan u, where u is cosine x. Then to find dy by dx, we just multiply dy by du times du by dx. The chain rule. So we'll carry on this. The first step, dy by du. Here's dy by du. dy by du is, what's the derivative of tan? Is 6 square u. Then du by dx. du by dx. du by dx. Here's u. What's the derivative of cosine? Cosine starts with letter C. As we said, the derivative will be have minus. Minus what? Minus sine x. Then we multiply these two answers together, and again we make substituting u is cosine x. So the answer will be, to write the dy by dx, dy by dx is equal minus sine x, as we multiply those together, times 6 square, and again we replace u by putting cosine x. So this cosine x. And that's it. I hope you understand how to apply all these rules to find the derivatives for any function. I'll see you next time, also to explain another topic in the calculus. Thank you for watching. See you again.